Today I'm going to briefly talk about testing and debugging. This is the important part of the software development life cycle, where you are expected to test and debug the program you wrote. And it is important for when you are doing software development. In any case, whether you are building SQL or where you are building the C++ code, Python code, Java code, testing and debugging is an important part of the process. And I'm borrowing this slide from the MIT lecture 6001. And one of the things that is shown here is that programming challenges, there is expectation and there is reality, and this the picture on the left hand side is about a girl who miraculously rides a bicycle and parks in the wall, and on the right hand side there's a boy who tries to um, build a domino and um, um, try to create domino effect by pushing one domino, and all the wall falls to the same sequentially after he pushes a domino. So he's trying to build, but he doesn't actually do that, so it is just showing the difference between expectation and reality. And here now we have is when we are writing a program, we always aim for the high quality, but it doesn't really happen. So what happens is that sometimes when you write the code, um, taking the analogy from Professor Srini Devdas, it's like building program is like building a soup, So when you're building a soup, and bug is falling from the ceiling, what would you do? And he says that either you can check for bugs, or that you can keep the lid closed, or you can clean the kitchen. And checking the soup for bugs is just like akin to testing for a bugs in the lid. And keeping lids closed is akin to defense programming, and cleaning the kitchen is akin to eliminating source of bugs like debugging. So uh, debugging. So defensive programming is basically writing specification for a function, modularizing the programs, and checking contents for inputs and outputs. It's having assertions at the in every module. For every function, every module having some assertions, and modularize a program, like a breaking program into not building a monolithic program, but like breaking the program into small modules. Uh, and breaking down into function wise, module wise, like having its own purpose and specificity, and one is like a one, not put everything into one bucket. That's what the modularizing means. And it can be further. Defensive programming can be divided into two parts. One is the testing and validation, and one is debugging. Testing and validation is like comparing input and output to a specification. We have a specification which is kind of requirement for each function, and you compare like input and output, and is it working or no? How does it work compared to the compare specification? And also how can I break the program? It's like trying to attack the program to make it break, such that we are making it stronger, and trying to find the bugs. And then it's a debugging. It is like a it is trying to understand what caused the bug, why it is not working, and how can I fix my program. So these are two branches of defensive programming. And then we'll move on to other slide in few minutes. So now I'm going to talk about how to set up the programming for easy debugging testing. So first thing we have to do is we have to break our programming into different modules, so that not everything is put into same module. Function are broken into the intuitive parts. Uh, in this way, things are easy to debug when something breaks. And the second thing is that we have to write the doc string for each functions and models, so that we know that what are the expected input and what are the expected output. And this will become really important when we do the testing later on. And also document assumptions in the doc string itself. So like when we are doing testing, this will help us to create test cases too. So this is these are really good advices, and these are similar to the motherhood and apple pie, something that are universally appreciated and cannot be questioned. So I suggest you guys do this well when you are programming. So when I'm ready to test, the first thing you need to make sure is that actually program runs. There are no syntax errors, there are no static semantic errors, and actually a Python interpreter will help you to find a semantic errors which are easy to find. And the second thing is that you have to set expectation and results, like what are the inputs and what are the outputs for each of these inputs, and this should be documented somewhere and for example in the test cases. So these are all the important things that you need for starting testing. And second, now we'll move on to like what are class of tests we do. The unit testing is actually testing each function of the program and whether they work individually. And the second thing is that like once you find a bug in a program, then you have to do all the tests you did previously for a particular unit test. Then that is called regression testing. When you find a bug and then you fix the bug and then you do all the tests you did previously for that unit, that is called regression testing. And integration testing is like whether all the units are working together in a seamless manner. That is called integration testing. So these are three types of testing usually a programmer does. And the third, there are like three different approaches to testing. One is intuition testing, one is the black box testing, and one is glass box testing. Intuition testing is where you do the testing based upon your intuition without any following a strategy. You just do the random go. You just do a test based upon the natural boundary of the code, or you do the random testing. Second is a black box testing, where you go through the specification requirement and test the code based upon that. And third is actually you look at the code and go through the and make sure that you run the code through all the paths that is inside the code. Black box testing. Black box testing is so let's briefly talk more about black box testing, where you go inside the where you go through the specification and make sure like you have test cases for all the paths through the specification. And here we do not look at the code itself, and this is important because when you do black box testing, you are not actually looking at the code, and it can be done by someone who has not who is not a coder himself. And if something changes in the code, then this black box testing can be reused. And here's an example of like one of the example where how do you do the black box testing for a finding a square root. Glass box testing is where you actually look through the code and make sure that you iterate through each part of the code itself, and at least one more time, at least one time. So like when you want the draw. No, so one of the drawback is that like sometimes you may miss a path, and sometimes you may go through a loop arbitrarily many times. So what are good guidelines for this glass box testing? One is like you go through all the branches and you go through for loops. You actually don't go through loop, or you go through loop only one time, and you go through loop more than one time. And and also like for a while loop, also make sure that there is always exit for a while loop. Like it doesn't go infinitely, that's one of the thing for glassbox testing. And here's an example of the glassbox testing where you have like a bug here, like in this absolute function. This function, when you go through the code, you see that like when you do -1, it returns -1, but it should run 1 here, and this bug is missed because it was not tested properly. So this is one of those boundary cases where glassbox testing is useful.